Number 22. Given the standard 8x8 chessboard, how many rectangles of all possible sizes can you find along the grid of the chessboard? Yeah. So here, the main difficulty here is the characterization of the data. How to characterization of the data. Here are our data, the rectangles. Yeah. How to choose different categories to organize our data. So that's the main problem we want to solve. All right. Yep. So regarding the rectangles, we need to look at the shapes of the rectangles. Yeah. The first special shape, yeah. The first one, squares, right? We know squares are special rectangles. So the first category, we count total number of squares of different sizes. And that's we did before, right? The known. So this answer is known. All right. Then the second type of rectangle, we consider the rectangles non-square. Yeah. So the remaining, after the first one, we need to characterize the non-square rectangles. Yeah. For the non-square rectangles, there are two orientations. Yeah. First one, we look at the horizontal. Horizontal orientation. Yeah. And the third one, vertical orientation. But vertical and horizontal, we can see they are symmetric, right? Horizontal, vertical, they are symmetric. So the number of vertical rectangles equals the number of horizontal rectangles, right? Yeah. So the third one, we do not need to calculate. We just use the same number from type 2. Yeah. So vertical orientation. Okay. So now we only need to calculate type 2. Yeah. Type 2, how to describe, yeah, so here let me draw a standard chessboard, 8x8, okay, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, and one more here. All right. Although we can draw black, white, yeah, but that's not important. Okay, black square, white square, the pattern for this question, it's not important. All right. Then, so how do we describe horizontal rectangles? Yeah. So we imagine the shape is like this. Okay, the shape of a horizontal rectangle like this. A side to B side, but with A less than B. How about that? Okay, so with this property, we treat as the horizontal rectangles. Okay, all right, yeah. Then the characterization. Yeah. All right, so 2.1. 2.1. How many 1 times B? Yeah, A equals 1. Okay, A equals 1. 1 times B. 2.2. How many 2 times B? Okay, make sure A is strictly less than B. Okay, 2.3. How many 3 times B? Okay, 2.4. How many 4 times B? Okay, 2.5. How many rectangles with 5 times B? Okay, and 2.6. How many rectangles with 6 times B? Okay, 2.7. How many rectangles with 7 times B? Okay, and then no 2.8, right? Because if A equals 8, then there is no B, right? Because B must be strictly greater than A. So the last case for 2.7, yeah, it must be 7 times 8, right? 7 times 8 rectangle. Yeah. B can only take 8, the last case. Yeah. So if you can calculate, you count the number of, for each subcase, you can find the subtotal, then you add them up. So you get the number of horizontal rectangles. Yeah. Then for the number of vertical, you do not need to recalculate it. Because by symmetry, you just use the same number for the number of vertical orientation rectangles by symmetry. You just swap A and B, right? The vertical, swap A and B, okay? Yeah. Or A here, B here, right? Vertical orientation. Then you should get the same number. Okay, all right. So that's the hint for this question.